Hello and welcome to Aunt Math. In this edition of Aunt Math, we're going to talk about synthetic division and substitution. We want to find factors of polynomials, rewrite polynomials in factored form, rewrite polynomials in standard form, and identify the degree, type, leading term, leading coefficient, understand the relationship of factors in synthetic division versus long division, and identify if a value is 0. Right, so polynomial is a function with many terms in the form ax to the n plus bx, the n minus 1 plus c, if there is a value for c. So n cannot be a negative integer. In this case, so the function of x is equal to 7x squared plus x minus 1. That is a polynomial function. However, f of x is equal to x squared plus 1 over x, where 1 over x is equal to x to the negative 1. Since we have a negative integer here, for n, we don't consider this a polynomial function. All right, so some terms that you need to know when we're dealing with polynomials. Polynomial means many, nomial means name or term. So constant 5, linear function 3x plus 2, so just one value with an exponent of 1 here. Quadratic now, polynomial, many terms. X squared minus 2x plus 4 is an example. So the highest exponent value is 2. Cubic highest exponent value is 3. Quartic 4. Quintic is 5. So I'm not necessarily going to test my students on this, but I want them to be able to understand what type of polynomial function is described in a homework or test situation. All right, so let's talk about leading term. Leading term is the entire entity here, both coefficient, the variable, and the exponent of the value that has the highest degree exponent. So it doesn't really matter where the placement is. The leading term is always going to be that value, that set of numbers and variables combined together with the highest degree exponent. So the leading term in this case is 7x cubed. The leading coefficient is 7. And this is a cubic polynomial. All right, so that the leading term describes the type of polynomial. All right, so for each polynomial, provide the leading term, leading coefficient, the degree, and the name. So I'm going to ask you to take care of this, and then I'm going to come back and give you the answer. All right, so again, we look to the term with the highest degree. It's 5x squared. That's our leading term. Leading coefficient here is 5. The degree is 2. So here's the degree, it's 2, and then it's a quadratic function. For the next polynomial function, here is the term with the highest degree, so this is the leading term. Coefficient, leading coefficient is going to be 1, degree is 4, and this is a quartic polynomial. Okay, so now I want you to use synthetic substitution in order to find the function p of x when x is equal to 2, and that's what this p of 2 means. Here's my function p of x. Here's my polynomial. So find p of x when p is equal to 2. I'm going to stop here while you figure this out. All right, so I'm going to substitute 2 in for x. So 3 times 16 minus 7 times x cubed, which is 8, minus 5 times 4 plus 9 times 2 plus 10 is equal to 0. We call this direct substitution. We're directly substituting 2 in for x. All right, so let's talk about synthetic substitution. Synthetic substitution uses a different process, and it gives us something a little bit different, but direct and synthetic substitution are very close twins, we'll say. So what we're going to do is we're going to take the coefficient, we're going to line the terms from leading term onto the constant. 4, 3, 2, 1 are the exponents. We're going to take the coefficients for each of these. We're going to move these to a placement here in order. We're going to draw our backwards L to create the synthetic division. We're going to use the substitution value here as 2. And then we're going to go through the process of finding whether or not 2 is a 0 using synthetic substitution here. So the first thing you're going to do is drop the 3 down below the line. Then the next operation is to multiply 2 by 3 to get a product of 6. Add negative 6 or set negative 7 and 6 together to get negative 1. Multiply 2 times negative 1. Add the 2 together, and so on and so forth. So I'm going to ask you to complete this and come up with a value. I'm going to pause here. All right, so you should get negative 1 times 2, negative 2, plus negative 5, negative 7, times 2, negative 14, plus 9, negative 5. Negative 5 times 2, negative 10. 10 and negative 10 leaves us with 0. So when we find 2, and we substitute 2 in, we get a 0 result. So what this is telling us is that at the value x, 2, we have the value y, which is 0. So we know that this polynomial function crosses the x-axis somewhere in some direction at 2, 0. I shouldn't say somewhere. It definitely crosses the x-axis at 2, 0. Okay, so now I want you to find p of 2 and p of 3 for this polynomial function using direct substitution, or you can use synthetic substitution as well, either direct or synthetic substitution. Let's see what you come up with. I'm going to pause here. All right, so I use synthetic substitution in this case, and here are my results. You can take a look at the work on your own and pause if needed for the first and the second. So we can see for both first and second, we don't have a 0 value at the end. So it means that both 2 and 3, or x minus 2 and x minus 3, are not roots of the polynomial. All right, so let's move on. Actually, we're going to stop here. And that's it for this edition of Otten Math on zeros and factors of polynomials. In the next edition, we're going to talk about the remainder and factor theorems. So please come and join us for that next video in the next edition of Otten Math.